All right, cool. All right. Hello, everybody. So this will be my talk on an overview of technical animation. This is my talk on an overview of technical animation as part of Tech Arts Meetup and Unreal Dallas chapter. So first off, who am I? My name is Gabriel Salomone. I'm a technical animator and a bit of a combat designer. You'll see that a little bit here, but these are some of the projects that I've worked on doing like a lot of the animation side of things. And you'll see a few of them as we kind of go on, and like you'll see more of that. So first off, what is technical animation? This is probably one of the biggest questions that are sort of lingering. It's a pretty new and upcoming term for the industry. The way that I like to think of it is a sort of collaboration between these three disciplines. So there's 3D rigging, 3D animation, and game implementation. It's kind of like a harmony between all three of these. I will say for job posts and stuff, you might see like a technical animation job post, and that might people have like different meanings of it. So it could mean like, oh, you like create like 3D rigs for someone, or maybe you make tools for 3D animation. But the way that I sort of see it is a little bit more focused on the game implementation side of things. So making sure that like the rigs and the animations are able to export properly into the game engine, and that you can like sort of work with the animations within the software. So if you've heard of the term like animation programmer, that would usually be like what a technical animator or someone with the game implementation side of thing would sort of be focused on. So for this talk, who might this talk be for? If you're an animator, if you are a rigging artist, a tech artist, or if you're just curious about what technical animation is or how game animation might work and stuff, then this talk will be very much for you. And even if you're not, I'm sure you'll still get a lot out of this. The talk will be dense. I want to make sure that I throw in as much information as I can, but still, hopefully I don't overload your brains. The structure that I'll be going through for this talk, I'll start off with rigs and animations. I'll talk about how to get those game ready so you can be able to import them into a game engine, or even like any other software of choice even. Some in-engine tools for you to utilize if you're using Unreal or Unity or anything. The process, we're going to go through the whole process of the game animation pipeline from rigs, animation, and then implementation, as well as some things to keep in mind that like might be good practices or some areas where you might falter, and try and like kind of save you from those. By the end of this, you should be a lot better at managing how making proper animations for your games. For this talk, I'm a little bit more comfortable with Blender and Unreal, so and as well as a lot of the stuff that I made have been using those. So that's what this talk will kind of have in mind. But I made sure that the theory and the principle for everything is applicable to every program. So it doesn't matter if you're using Maya and then you're going into Unity, or if you're using 3ds Max to Godot. This should be all very familiar. So starting off with the rigs. The first thing to know is constraints do not transfer out of the program that you're using. The animation that you make with your animation gets baked down to whatever it is, and the constraints get applied and completely removed. This is also fairly similar to like lattices or matrices, expressions, stuff like that. So this is one of the biggest things to kind of keep in mind if you're making rigs for a game. And this happens right when you export out of the program. This is not a issue between programs. This isn't like, oh, like Unity doesn't quite know what I'm doing with this. No, this is specifically a problem when you export and then try and like import something back in. So here, for example, I have a rig that I made. It's super simple. So all it has is just like a copy transform constraint from one set of bones that deform the mesh to another set of bones that act as like the control rig. You could kind of imagine this as like your more like feature-rich rig that has all these different mechanics and stuff in it. When I export and import it, even to the exact same program, you can see the constraints are no longer there. These bones on the right side are effectively dead. They don't do anything. And then the ones on the left, I can just move around on my own time. So this can be a huge headache for if you're trying to make animations for games or even rigs and such. So definitely, this is something to keep in mind for sure. You can see here is one of my feature-rich rigs that I made, and you can see that on the left side we have like all those like IK switches and stuff. Here I selected a bone that has an IK constraint on it, and then you can see on the right side that's with it imported back into the same program, and like all the colors are gone, all the like custom controls, everything is gone, and I selected the exact same bone, and you can see the constraint is completely missing. So if you move that bone, then nothing will happen. Aside from like maybe some parenting stuff if that's what you work with, but specifically constraints. Those are the big part. And what happens when you export? Unreal has like those bones grayed out, and you can see they're just kind of like floating there. And if you're working with something a lot bigger, you can. I'm sure if you've tried exporting into a game engine, you've probably seen something like this, where it's just a giant mess of bones, and like nothing's really there. Like you only move like a handful of bones, and some of them work, but some of them don't. It's very messy. So, what are some things that we can do to fix this? The biggest one is to split your rig into pieces. So the biggest thing that you can do is create a game rig or deform rig layer. And then this is like, okay, these are only the bones that I'm going to export into the game engine. So you want these to be only the bones that will deform the mesh in some way, or potentially a few extra bones that you want to throw into the game engine. The target rig layer is something you can make as like an in-between or like a translator for your deformation rig, so that like what you do is just constrain the deformation bone to the target bones, and then now you just hide the deform layer, and then you only work from the target bones and on, and then you can freely make your controls. You can freely like mess with the parenting structure. You can freely mess with constraints and what have you, to be able to make sure that your animations in your DCC works properly. If you're in Maya as well, then like you might want to make these groups down here, like a mesh group or a deformation group, for to kind of like keep your rigs a little bit more centralized, and then you make a separate control group that you constrain everything to be able to still work with your rigs as it is. For when you're ready to export, uh, in Maya, because you have like those different groups that you solidify, you can just take the mesh and the deform group of bones and only export those out. Or if you're in Blender, they have this handy little like deform checkbox that you can tick on each bone. If you want to like batch select bones and mess with that, you can go here to armature, bone settings, and deform. And then when you go to export, there's this handy only deform bones checkbox. So that'll check every bone for these little checkboxes to see, okay, which one is checked, which ones do we want to actually send out. Um, so if you do this, then your rig will go from this with like a little bit more dead bones and everything to just the ones that you need that are necessary. And on the more complex rig with the giant mess of bones, it gets cleaned up to only the things that are necessary. And also don't worry about your animations either, because those get baked down to the deform bones, then you don't have to worry about carrying in any unnecessary weight. For rigs, one of the biggest problems though is also scaling. If translation and rotation usually work perfectly fine with when importing into a game engine, but scaling can get a little bit messy. So when you have a rig like this, where it's just like a stretch two constraint, you just move the one bone up and then the bottom one stretches, it doesn't seem to be like that much of an issue. But under the hood, this is what's actually happening. And when you export, it will look like this. Even when you just do the export, as well as like when you show it in engine, it'll still look like this. So the scaling can get really messy. And the problem with this, or the reason why this happens, is specifically from parent-child relationships between the bones. So if your parent is scaling and the child isn't, then the child will inherit whatever scaling is happening on it, and it is under the hood. It will be invisible to you if you're using like your rigs and animations in Blender or Maya. So to kind of combat this, there are two solutions. The first one is to have your entire rig be a completely flat hierarchy, where nothing is a child of anything. Everything is just itself, no parents, nothing. This can work. This will be a fast and easy solution. It will work. However, if you wanted to do any extra stuff in your engine, like, oh, like I want to like move the arm a little bit to the side, you'll notice that like the forearm and the hands and the fingers and stuff will not follow it, because there's nothing for it to parent to. So if scaling is the most important thing and you're not going to be doing anything in engine, then you might consider that. But the most bulletproof way, that like slightly more complex but like easily like preventable solution, is on the right there. I have on the child bone that's an issue, I create a copy scale constraint and have it copy the scale of the root. So that will just override anything that's happening underneath it and make sure the scaling is properly whatever it should be, as it currently is. If you want any more like details on like game rigging stuff, this video is also fantastic for this. It's specifically within Blender, but again, like the same principles can apply. So if you're curious about like more information on uneven scaling, as well as like, okay, like how to get like game engine units to properly line up, or if you have a rig that you already made and you want to update it to be able to work within a game engine, this video will be your guide. So with the rigs done, now we can head over to animations. So this will be more for like if you're making a game and you want to make sure that the game animations actually play like really nicely. So some things to keep in mind. The way that I like to think of animations and kind of categorize them is with this, starting from the top down of importance in terms of player expression, and from the bottom up for, I guess, immersion. The top one is what I like to call hero animations. So these are the ones that kind of reflect the game state in some way. So if you're pressing a button and you do an attack, then these things kind of overwrite everything underneath. You'll do an attack. If you get like hit and you get like a hit stun or something, you want that to play over everything else as soon as possible. Every frame is very important to the feel of the game and how the player kind of visualizes their response to it. The second layer is locomotion. So this is just kind of like everything that sort of happens while you're playing the game. So like your basic movement, you're walking, you're running, you're idle, you're like maybe walking on a tightrope or something. That would be kind of like your locomotion system. And then underneath that is what I like to call support. So these are like for if you want to like really enhance the level of immersion for your game, you want to make a lot of these smaller helper transition animations to kind of make sure that everything feels nice and clean. So like this example on the side, on the left there, the base, that's just with locomotion alone. All I'm doing is just idling and then I walk and it plays a walk animation. But on the right there, that's a game animation sample project. So that has a lot of those support animations where, when the player goes to stop, they'll like do a change of weight and kind of transition to their idle state. So this can be really beneficial, but it's also probably a little bit more like at this point you're going into motion capture, or like if you're at a bigger studio with higher budgets and stuff, that's kind of where you'll probably see a lot of these. So make sure you keep some of those in mind. Here I kind of annotated a game that I played and just kind of like highlighted what I kind of perceived to be like the hero animations with the player actions, some support animations that kind of help to like build up the immersion in the world, and the locomotion stuff of just like, okay, I'm walking around, I'm just kind of doing whatever. So like for stuff like sheathing your sword, that doesn't really add much to the game, but it still adds a lot of immersion. So I like to call that like a support animation. It's not necessary, but it's still really good. For this talk, I want to specifically highlight the hero animations because they reflect the gameplay so much. I did want to talk a lot about it. This is also kind of where my combat design sort of aspect sort of comes into play. So the biggest thing for more arcadey, faster paced games, as well as just like any game where you think like the player's response is important, the biggest thing to keep in mind when you're making animations is not to worry about the anticipation as much. If you're making a film, you might like have the player start into an action, they'll be in one pose and then they'll kind of like shift over to another one, and that feels nice and natural. With a game engine, the player presses a button and then they see the dramatic shift. So here, like Sakurai, when he was making Smash Brothers, he made this sort of video talking about this. And he says the moment the button is pressed, the character's pose drastically changes. Normally, you would interpolate from the standby pose to try and avoid the animation skip, but we can let players know right away that their input was received. So we do our best to provide immediate feedback to the player. This is super important. So make sure that like if you're making animations and you want to make sure that like everything feels snappy and responsive, you want to make sure that you completely change up the pose and you don't worry about that animation skip, because in a game that does not matter nearly as much. uh, as well for if you're making a more competitive styled game. In general, even make sure to telegraph your actions with strong silhouettes. You don't want two poses to be really close together, but they do two wildly different things. So with this is all those three animations are only a single frame off from the idle pose of Mario here. So you can easily tell if you played enough Smash Bros. You can easily tell which attack these ones are just from a glance. And as a player, you'll be very very thankful of that as well, to be able to tell, oh, like that Mario's kind of doing this upper strike. You know that he's going to strike above you, or he's charging the side attack, so you know that it's going to come onto the side. For more PvE focused games, you want to make sure that you're keeping in mind the player balance and the enemy balance, and making those two kind of work together in a nice way. So for player animations on the left, player animations need to start quick and end fairly quick as well. They shouldn't really linger too long. Like you shouldn't have them like kind of wind up an attack, or like they finish their attack and they're kind of waiting while it goes on. Unless you're like giving an excuse. Like for example, for Souls games, the whole point of those games is that like if you press an attack, then you're kind of in a period where you could be punished. So every attack matters. But generally, you do want to make sure that players' inputs are fast, because if the player wants to attack, they'll press the button and they want to see an attack come out. And then if they're ready to dodge, then they should be able to dodge pretty quickly too. The other excuses, I guess, for if you don't want it to be quite as fast is if you're having the player charge up a really big attack after a lot of previous attacks, or if you're giving them like some kind of gameplay excuse, like giving them iframes or like parry frames while they're like in the middle of this really long attack. Um, on the enemy side of things, it's kind of the opposite. You want enemies to be a lot slower, and you want them to be highly, highly telegraphed in the same way that I showed in that slide before, because that way, then the player can tell like exactly what is happening and can be able to properly work against them. So for this example with Venom, he like pulls his arm back, he charges it up. You've been telegraphed, oh, this is the attack that's about to come up, and then he'll like run up and then strike down. There's like more than enough time in there for players to like respond and react and be like, oh, okay, this attack is coming up. I should learn to dodge through this. It gives them a lot of time to kind of work around that, as well as after he attacks then there's still like that window of time afterwards where you can be like, okay, he's done. Let me go in for my attack now. And because yours is faster, you'll be able to work around that. So here is an example that I pulled from Kingdom Hearts, one of my favorite games. I think it does a really good job of explaining this as well. So this enemy here, he pulls out his spear, he's like pulls back, he lifts his leg, and he gets ready for this giant swing. He finally swings, and then he takes a second to kind of recoil back from it. So players know instantly what's about to happen, and they can react accordingly. On the right side, you can see that the player is able to act a lot faster. So when the player sees that this is coming, they can be like, "Oh, that's about to come up. Let me run up and start blocking." And then you can run up, you can press the block button, and it'll immediately cancel out of it. And he also has a lot of hit stun time afterwards, so that you can be able to go in and punish him. If you mess this up, this is what can happen. So if you have two slow player attacks on the left, you can see that the player throws the sword. It takes a while for it to kind of come back. It might be kind of cool and flashy when you're doing animations, but when you're in game, this can feel like really annoying, and you'll be like, "Oh man, this game is super cheap. Like I just like was sitting there. I was a sitting duck, not really doing anything, and the enemy was able to just come up behind me and just hit me with it." On the right side, the opposite. If you have fast enemy attacks, then the players might think that that's cheap, because they're like, oh, like I had no time to react to that. Where was that swing coming from? There was no telegraphing whatsoever. There's no time for the player to internalize what is happening until after the fact. And in this instance, I got one shot. For animations as well, one of the big things that you probably hear a lot with film is to play to the camera. This also works in games as well. For 2D focused games or for cinematics, this will be very similar to probably what you're already used to. You have the one camera angle that you can focus on, and you can kind of work around that to your benefit. So if many of you guys have seen Dragon Ball Fighters, on the right here, it's a beautiful cinematic, it's super anime and stylized. But then on the left, when you break the camera out, you can see the arm gets twice as big as the actual character himself. It's really funny, but it does work. It sells the image, and that's the most important part of this. However, if you're making a third-person game, something not many people really talk about, because you can move the camera in any space, you want to make sure that it still is able to play the camera as best as you can. So for this, here's another frame of an attack animation from Kingdom Hearts. I literally just threw in some frame and I started rotating around. You can see no matter which way I rotate the camera around, the pose and the silhouette is still perfectly clear and sharp. The legs are split out and they're bent a little bit, so that like in some angles it's a little bit like easier to read that. Even the arm is slightly bent with the elbow out, so you can see that, and then even like the hood as well. So just any angle that I sort of rotate this around, you can see that like the silhouette is still very strong. So make sure if you're doing third person animations that you keep those poses very clean. Now for after you have your rigs and animations and stuff, now we'll be throwing them into the engine of choice. This would be probably where some of the tech animators come in, but I also wanted to keep this in mind for if you do rigging or animation to also make sure that you keep these in mind when you're making your rigs and animations. The first one, if you've messed with animations before, you already know about animation graphs. But if not, animation graphs are where you go to slot in the majority of your animations, especially the like support and locomotion style animations. So that when you walk in a certain direction, then this animation plays. If you stop, then that animation will play. Like whatever kind of like state happens, that the animation reflects it. Um, so if you never messed with it before, then definitely keep this in mind. Uh, the other thing that I think is pretty important that I don't see many people like really use too much, at least in like as like a junior, like they're still kind of messing with it, is blend times. So here for hero animations, especially if you want that Arcadian player responsive feel, you want those attacks to feel instant. And by default, Unreal has the blend time set to all animations as 0.2 blend. So that'll blend whatever the current animation is with the new one in like however much time that you set there. So on the left, it's set to 0.2. It shoots and it looks fairly good, but but if you're playing the game, it's really hard to tell like, okay, when was my shot actually kind of showing up? Whereas on the left, I completely set it to 0. You can see that the gun is super snappy, as well as the camera as well. You can easily be able to recognize in the moment, oh, I just pressed that button. Oh, that felt really good and very snappy and responsive. So make sure that you kind of keep the blend times in mind. As well, also for if you're wanting to go more in the immersion route, you might want to throw on the blend time a little bit higher, especially for locomotion and support. This is more so for heroes stuff to turn it down. Root motion, super important if you're really curious about trying to get really complex sort of movements and animation styles. So instead of having your programmer or your designer kind of work with these like arbitrary values of moving the character around, you can straight up just animate it. You just take the root controller, you just move it in your scene, and then because the root bone should be like the highest bone in your entire hierarchy, then whenever you click the enable root motion in your engine, then the animation will actually override the player's movement in game to be able to do this attack. So you can get a lot of really complex stuff in it. You can just animate your character in engine effectively, which is really cool. One of the biggest things I would probably talk to a lot of people about this. This is one of my big brain moments. Like you can do that. Was animation notifies or animation states as they're called. So these let you run functionality in the middle of an animation, like on a per frame basis, which is incredible. So here I have this attack animation that I threw out, and then I have like all these little things kind of slided out onto the timeline here. And I'm not so sure if you can read some of them, but here at the very beginning, I have the character rotate to the target for these like first 10 frames. And then they have like a window where they can block the enemy's attack. And then down here, I have a bunch of different points where the player can do damage. So it'll like spawn hitboxes on each and every one of those. And one of the cool things as well is I'm able to like not only hook those up, but also even like assign values and variables that I can assign to this to say, okay, this attack at this frame does this amount of damage, does this amount of like knockback, it has this radius around it and such. So you can get really into the weeds with this. I even set it up as well for like animation canceling. So you can dodge cancel if you're in this window or attack cancel and kind of go into your next combo state. Super, super powerful. Definitely make use of it. But not only is it useful for gameplay as well, but it's useful for all kinds of things. So if you want to time sound effects to the animation, like for just the walking animation, then every like step you take that it plays a footstep sound, you can go to that frame of the animation and say play sound, and then kind of have it work from there. You can have it create VFX, like have it like spawn in the arm on like a certain frame, or like spawn projectiles as well. There's a lot of different uses for it. So definitely, even if you're like not doing gameplay stuff, definitely keep it in mind if you're wanting to make your animations feel a lot better. Sockets. This one is pretty massive. If you're one of the rigging artists that thought you got a lot out of it, think again. So with sockets, you can be able to hook up multiple different assets together in Engine. So in this case, I have two separate rigs with two separate models, two separate like animation sets with the arm and the gun models, and then I'm still able to hook them up in Engine and be able to play them together, or even just like hook them up to like the same assets. So for this example, I have this character. They're swinging a scythe around. What I did is in Blender, I have on the character this socket bone, the deformation socket right there, and then I have like a controller to it so that I can animate the socket, and then I just like attach the asset of the scythe in place so that I know what I'm kind of working with. And then when I'm in Engine, then all I can do is just throw in the asset, zero it out, and then attach it to the socket, and the animation will be hooked up, and it'll look really smooth. It's effectively like a parent-child constraint inside of your game engines. In Unreal, they are called sockets. I'm sure they're like under a different name with Unity or Godot, but these are some of the nodes that you also have available in Unreal that makes that parent-child constraint work. But this is also really helpful for if you have the player like swap out different armor sets and you want the armor to show up like on the chest, or like have like VFX like I showed earlier with like or said earlier with like the like fire effect spawning on the arm. You can have it attach to the arm's like bones itself, so that when you move the arm, that the VFX follows it. You can use it for so many different things as well. So definitely definitely keep that in mind. If Also watch out for my rigging artists to also watch the like rotation points of it, because like in this example I just did like the socket and I attached the weapon to it, and then normally I'd probably just like tweak it. I'd be like, oh, let me just rotate it back into place and try to make sure that the gun is properly like held in the hand and such. You don't want to do this. Trust me. The easiest way to do this is to make sure that your socket bone and whatever the root bone of your last joint was have the exact same axes line up, so that when you just click this little parent constraint, that it immediately snaps into the position that you want it to. This will save you a lot of time. It'll be a lot easier, and then when you go into your engine, there will be no surprises. So for this, here's an example that I did for hooking up all these different assets together using sockets. So I have on the Blender side on the right, those are three different assets that I'm animating in Blender that I'm still able to hook up in Unreal and get the same effect. So I have the arms, the hands that are like doing this little like whip animation. I have the gun that plays like the gun slide going back and forth at a certain frame, and then I'm even animating the camera to kind of give this little like motion shake sort of effect. And then in Engine, all I'm doing is just taking these three animations and hooking them together, and then making sure that they all play at the same time and like hooked up to the right socket points, and all the animations play all together. Blend spaces and additive animations, these are really good for getting into like the more immersion level support animations or locomotion. So typically a lot of people do use this for directional animations, and you should definitely keep this in mind as well. So like if the player's walking backwards, then you have like a backwards animation, you have a sideways animation, and then you can go into your blend space and be able to like make it kind of work with whatever direction you're using, and then you can feed in the values to be able to say, oh, the player is moving left, play this like left animation, slot that on the graph. But another thing you can also do is you can use it for poses. For this example, I have the player like walking around, and the gun kind of reacts to whichever way you're moving. The way that I set that up is I made like one little quick animation with the four different poses. Here's like the idle, the like when I'm walking backwards, or I'm walking to the left, to the right, and I set those as like different frames. And then in Engine, I made a little blend space for that where I just slotted in like whatever my left pose was, whatever my right pose was, and just kind of moved them across the blend space graph there. And then within my animation graph, then I just slot in the player's velocity into the blend space, and then have it additively apply on top of whatever animations were previously on top of it. Another thing that you can do is animation layering. So say you have these two animations that you want to kind of put together. There's like the running animation, the player just like runs in place, and then the other one for the player to like hold the weapon and aim up and down. At first you might be like, okay, well, like if I'm overriding one animation with the other, then how am I going to get the player to hold the gun and run at the same time? Or like how am I going to have them to look up and down while they're running? Animation layering can be really massive for this. So here's an example of just like the player running around and they have their run animation working, but then they pick up the weapon and they're still able to run with their bottom half of their body, but the top half is now holding the gun. It's still aiming up and down. And so the way that animation layering kind of works is it's sort of masking different parts of the body, and then you can apply animations on top of it, on top of that mask. So you can kind of use this as like a filter in some ways. So on the top here, this is the main way that it's used, is having like the top. It's just like all the main animations that play, and then through this like blend pose 0, the like next layer, these are only the animations that play on the upper half of the body. And then on this actual node itself, then there's this little like filter here where I can specify what bone and that like it filters from. And then the bone depth kind of tells like, okay, how many children should it affect? So if you wanted to only affect the arm, but maybe not the fingers, you could probably do something like that. As well, also, if you're curious about like that animation earlier of like different aiming patterns and you want to figure out that, I also have this set up here with like a sequence evaluator where I throw in some values I plug into it to say like, okay, if the player's aiming at this point, then go to this frame of the animation and such. But yeah, definitely like if you have players like attack and you want them to still run while they're attacking and stuff, definitely use animation layering. The last thing that I'll talk about with like the kind of support level stuff is procedural animations. A lot of you guys probably already know some of this stuff, but you can use it for a lot of smaller things. So just like, okay, like foot IK is one of the biggest ones of like, oh, if I'm standing on a ledge and like the animation carries, but just the foot kind of readjusts into place. Or this other example of you're picking up an object and then your arm kind of like repositions itself to be able to pick up whatever object is in the scene. So you can use procedural animation to kind of enhance your animations using these, or if you want, you can just make it fully procedural. You can just do your whole animation pipeline with procedural stuff. So this example that like you move the camera around, you move the player, and then the legs procedurally place themselves around in a way that looks fairly convincing. If you've seen arc raiders, then I'm sure you've probably seen this sort of technology used a lot. But procedural animations can be used in a few different ways. You can either use it in your animation graph, like at the bottom, to say like, okay, here's like maybe some more support level stuff of just like having the foot placement kind of calculated out. Or you could have like, if your engine of choice has a lot of procedural systems you can utilize, and you can do that. Like Unreal's control rig is like massive for that. It's one of the biggest ways to be able to achieve a lot of these procedural animation setups. Some extra things that I either didn't have time to give on this talk, some things that I thought maybe were like a little simpler, or kind of like if you're already doing stuff you might know, or that I maybe thought was its own rabbit hole, would be animation retargeting, animation level of detail, so getting animations to kind of play at a lower frame rate if you're far away, general performance improvements like the culling of animations and such, physics assets for ragdolls or other things, procedural secondary animations. So like if you want like the clothes to kind of flap in the wind, or the hair, or like some earrings and stuff to kind of move and react to the world. Engine specific pipelines I didn't really cover too much, like Unreal's control rig. Again, that's a whole rabbit hole of its own. As well as the sequencer, which are kind of just like cinematics, or like if you know the dope sheet and stuff, you kind of know a good amount of the sequencer as well. But yeah, so go out there, make some animations. Thank you. There's my website on the left, as well as if you want to add me on LinkedIn, I have the QR code for that, as well as for the Unreal Dallas chapter there in the corner. But yeah, that was my talk. I hope you guys enjoyed it.